All right. Slides are up. You can hear me, so I think it's time to start. Welcome, everyone, to my talk, Prison Break When the Web Escapes the Browser. Just a disclaimer up front. I'm not going to do a bunch of Prison Break jokes, so if that's why you're here and because you're a big fan, I'm sorry, but I hope the talk is still going to be interesting. And I want to kick this off, actually, with a question while still some people are coming in. How many of you actually have some sort of microcontroller at home? Raise your hand, like if you have a Raspberry Pi, an Arduino, or anything like that. All right, and now keep it up if you ever used it for anything that isn't a blinking LED. All right, that's still a good amount of people. But I would like to see if I can inspire everyone in this room over the next hour to really start hardware hacking, and I want to try to give you an idea of how you can actually approach hardware hacking. Before we start, I would like to introduce myself. I'm Dominik. I work as a developer evangelist for Twilio out of Berlin. Twilio is a cloud communications platform. We have different APIs that allow developers to include different means of communication into your apps. We have a booth on the expo ground, so if you want to learn more about that, or if you have any questions about the talk afterwards, you can find me there. And I love writing JavaScript. I love writing JavaScript for the browser. I love writing it on the server. I love writing command line tools with it. And over the last year, roughly, I also started really loving writing JavaScript for hardware. Because previously, kind of like most people, I had a bunch of microcontrollers like Raspberry Pis and Arduinos flying around my apartment, always telling myself, I'm going to build something with this, but then I wouldn't really touch it. And at most, the things I would build would look like this. Just put like an LED in there and then like copy paste the code from the Arduino documentation and hey, it works, cool, I will test this out later. And the reason why this is typically the destiny of these things is that it's not as easy as doing software hacking. You know, like there's a bunch of additional things that make this way harder than if we just sit down and hack together a web app. First of all, it requires preparation. It requires you to have an idea of what you want to do and then have the right parts at home. And for that, you need to go out, buy them, etc. And that also means that it's higher in cost. You know, with so many different services these days that we have that allow you to do things for free or at low cost, like hosting things on Netlify costs zero. So like you can literally have a project up and running and pay nothing for it. And here you need to buy components and stuff. And then the other thing is there's no git revert or even command Z, you know. And that's, I think, the most scary thing for a lot of people. And I've been to hackathons where people try to do hardware hacking and burned all of their resistors at 4 a.m., try to get replacement parts at 4 a.m. in any city, and that's going to be difficult. But with all this negativity, let's switch it to something positive. It can be really rewarding once you actually have something going on. I feel way more rewarded when I have a hardware hacking project that finally works than if I have a web app that actually works. And the other thing for me that always kind of like pushed me back is that the typical go-to language for these projects is some flavor of C, C++. And I don't know about you, but for me, my knowledge of C and C++ is a bit outdated. The last time I wrote this was in university, and I don't remember much of that anymore. So kind of quickly hacking something together, if I constantly have to look up how to do things, doesn't really seem appealing to me. So today I want to show you 3 ways you can combine JavaScript with hardware to get going with hardware hacking. And the first approach is to use APIs and protocols. So here the idea is to use JavaScript to then trigger some API that is able to communicate with the C++ code that is running on the hardware to then control the hardware. And one example of that is the Particle Cloud API. So if you're not familiar with Particle, they produce a bunch of different microcontrollers. They have development boards, and then they also have these chips. The right one is the P0 chip, which is then on the left side on the actual development board. And the idea there is really that you can really easily get started and then later produce your own devices with it. But they focus on this one thing they focus on is the idea that you can have an online IDE, you can push updates to your devices, but you can also control the devices very easily via the Particle Cloud API. So it's a basic REST API that allows you to trigger remote functions on your devices. So basically you specify what device you want to trigger something on and the name of the function, in this case called brew, and then the code below that you can see is running on the device, where you during setup say, hey, there's a particle function called brew, and when that happens I want to trigger the following callback, and then you define this callback function in which you receive the arguments that you're passing in via this REST API. And this is a really easy way to get started, because this way you can kind of have then the basic logic that turns on the LEDs or reads the values, but then kind of move everything else off it. But if you don't want to be bound to kind of Particle, one common thing to use is MQTT, which is a lightweight machine-to-machine messaging protocol that relies on publishing and subscribing. In practice, this looks like this. You have some message broker in the middle, and sort of everyone can subscribe to so-called topics, which is a channel basically, and then every device can kind of publish to it so that others get notified about these that are listening on that topic. So in our case, we would have a computer and a server, for example, listening on the button topic. And then we have an Arduino device that would publish every time the button is pressed. It would publish an event to this MQTT topic, and the others would get notified. And this is really useful if you want to, for example, have a device running somewhere that constantly measures values, and then that device just pushes the raw values using MQTT into the cloud, and then you can do on your server or on any other device kind of the actual computations. And there are a bunch of benefits of this. First of all, there's no need for you to know the IP addresses of every device, because since every device just connects to the message to the broker, and it's really easy to scale, because if you want to have more devices, for example, in your household or out in the wild, then you can actually just attach them all to the broker, and it will be notified. And it's cross-platform and cross-language, since it's just a protocol. So there are implementations for all sorts of programming languages. Anything that can kind of speak TCP can run MQTT. There's an example how you use it in Node. You would use something like the MQTT library, connect to the broker, and then listen on the connect event, at which point you then subscribe to a topic. In this case, we're subscribing to the presence topic, and then also publish something to that topic, just like hello MQTT. And then we can listen on messages where we just get notified, hey, here's the topic that this was published to, and here's the actual message. You can do the same thing in C++. This is the code. If you have sharp eyes, you might be able to read it. But the concept is the very same. So we subscribe to a topic, serve in the same way. During setup, what we do is once we have the internet connection, we set a server and then connect to it using and specifying a client ID. And then in the loop of the device, we just continuously trigger the MQTT client loop, which just makes sure that it checks like, hey, is there a new message? And then we specify a callback function, which looks a bit more complicated because we're doing memory allocation and memory copying, and then we should not forget to free the memory. And this is sort of the thing where I'm like, hey, I'm for sure certain I will have some memory leak somewhere. But it's really cool to use, and I actually have an example. So my flatmate streams a lot on Twitch, and I don't want to annoy him constantly when he's actually streaming, so I wanted some sort of lamp that glows up when he's on air. So I built with a friend basically this. It's very simple. It's a Node MCU, which is based on a microcontroller called ESP8266, which is a super cheap microcontroller that costs around $2 if you order it on AliExpress. The development board costs like less than $10 on Amazon for sure. You can also buy them basically in bags because they're so cheap. And they're tiny, they're like this. And so I built this thing, and I figured I'm going to show you how it actually works. So you might have seen it's actually here. So this is the board, and the actual ESP8266 chip is just this. So let's hope everything is going to work. So I'm going to switch back here. I'm first going to show you the code on the on the ESP8266. So basically what I'm using is I need an MQTT broker. Twilio actually has one based on a product that we call Twilio Sync, which is for data synchronization. So I'm using that one, but you could swap in any other MQTT broker. It will just change the code that we use to trigger this. And then we specify a callback and create a pub sub client. So that's the library I'm using here to subscribe to MQTT. And I have some functions to actually then control the LED. But if we scroll further down, this is actually the one that is triggered whenever we have a new message. And in here, I do the memory copying and then parse the JSON object that I'm passing in and check for an LED property. And if it's on, I'll turn on the a built-in LED just for debugging purposes, and then also the LED matrix. And otherwise, I'll turn it off. So I'm just filling everything with zeros. And then I have the connect loop, which will just constantly check if it's connected, and otherwise kind of try to connect. And during setup, once the Wi-Fi is connected, so let's actually turn this off and turn this on again and see if it properly works. So when I turn this on, it will first start with like white LEDs, and once the Wi-Fi connection is there, so this is this part, once the Wi-Fi connection is there, I just turn it off and then start in a loop to kind of listen to this. And now I figured let's trigger this. So I can't ask my flatmate to go on and offline on Twitch right now. I think that would have been asking for a bit too much. So we're going to trigger this directly. So I'm going to use the Twilio library since this is powered by Twilio Sync. But otherwise, if you would use plain MQTT, you could do that as well. And then I also need a library just to do a bit of sleeping in between. And I need some configuration variables from my environment variables. So that's Twilio Sync Service and Twilio document name. And this is just so that I know what to update this for. And lastly, what I'm going to do is I'm going to grab this document. Cool. So I'm going to write an async function here to trigger this. Should catch any errors, just makes debugging this live a bit easier. And all we're going to do here is really update the document to set the data to have the LED property that we're listening on to on. And then we're going to sleep for 5 seconds so you actually see it pulsing. And then we're going to set the LED to off. I'm going to save this, and now let's run this. So I have a small helper library here that I wrote that will just pull in additional variables from a .env file. So that's basically just running Node, or it's not. It's Twilio Sync.services. That's better. Let's run this. And now, hopefully, there it is. It's pulsing. And after 5 seconds, it should be turning off. Yep, and it's turned off. So basically, under the hood, this is a basic version of the script. The actual one that I have is looking a bit more complex. So I'm basically just checking for using the Twitch API if he's online or not. But then under the hood, I'm just setting the same value if he's online or not. I actually need to update this to a serverless function since Twitch introduced by then a webhook that you can listen on. But previously, I kind of had to schedule a cron job. So that was just a script that was continuously running. All right, so we covered this. Let's jump back into the slides. Cool. So what are the pros and cons of this API approach? So as for pros, it's a lightweight and intuitive way to communicate between devices because it's just a publish-subscribe way in a lot of ways. Either be it something like the particle API, which under the hood basically just acts as a publish-subscribe as well, just in a slightly different way. And then that allows you to kind of move all the heavy business logic off your device, so you can use like any language that you're comfortable with, be it either JavaScript or C# or really any language that you feel comfortable with. You can use that one to then actually do the processing of the data. And it's programming language independent, so as I said, you can pick whatever you feel comfortable with. As for cons, you still have to write some C++ code for the actual hardware, so you still have to control kind of the LEDs and stuff, which is for sure the thing that took the most time on this project. But I had luckily one of my colleagues actually wrote code that allowed you to control this LED matrix, so I kind of just took that and then adjusted it. If you're planning to use MQTT, you need to deploy or use a message broker that is already existing. So either you need to run it on a server where you can actually expose the respective port, or you actually need to pay for it. So whatever kind of floats your boat. The next approach is called tethered node bots. So that's the idea of using Node.js on a machine and then controlling hardware directly with this. And the way this works is with an NPM module called serial port. So serial port is just an NPM module that allows you to use Node to control any device that is kind of connected via a serial port. And then there's a great library written based on this called Johnny 5. And Johnny 5 is this library that allows you to talk to microcontrollers using Node.js, using sort of the familiar syntax, how you would write JavaScript, and then leverage the entire NPM ecosystem, since you're essentially just writing Node. Now, the thing is that often you have to use it tethered, so that's why we're calling these like tethered node bots. And what that means is if you're trying to control an Arduino, for example, you have the problem that Arduinos can't execute Node, and therefore we need to have some host machine that executes the Node code, so you would have that connected to your machine. However, Johnny 5 has this concept of I/O plugins. So with these I/O plugins, you can also control other pieces, other microcontrollers. So if you, for example, want to control a Raspberry Pi, all you would have to do is you would basically write this code, use the Raspberry Pi I/O plugin, and then you could execute Node directly on that device to control then all the ports and stuff. Or similarly, there's an I/O plugin for the particles, for example, that is under the hood using the Particle Cloud API. And the nice thing is really how you write the code. So this is a Blink example copied straight from the documentation of Arduino. And we have the setup stage, this loop state that you saw before. And we define the pin mode of something. We set it to output in this case. And then we digitally write a high value, or we digitally write a low value to it. And then in between we have a delay. So this is just causing a blink. This is the same code written in Johnny 5. So we require the node module, we initialize an instance of it, and then this is where you would pass in an I/O plugin if you would use a different thing than an Arduino. And then when the board is ready, we initialize an LED, we pass in which pin it is at, in this case pin 13, and then we just say blink, and that's all we have to do, and it starts blinking. Now the code here is not significantly different, but where it's becoming nice is with buttons. So this is the code that would trigger in C++ to turn an LED on whenever a button is pressed. And the same code, and what we're doing here in the loop is basically we're constantly checking if the button state is high or low, and then respectively write the thing. Now this is the way you write it in Johnny 5, and I think this is cool because it shows sort of how JavaScript is, since it's very event-driven by nature, is a perfect match for hardware from its event-driven nature as well, because typically we want to listen on events. And that's what we're doing here. So we're listening for the event press and release of a button, and then we trigger LED on or LED off. And this is really easy, really nice for anyone who's never done hardware hacking before. You don't have to think about these concepts of looping things and a setup stage, etc. It's just like any other node code you wrote before. And I have an example for that as well called porg.js. And the idea was to build my own custom peripheral device, because I had a conversation with my colleague Marcus. He talked yesterday about hardware hacking with Android things. And what his opinion was like, well, if you have to connect a device to your computer, what's the entire purpose of controlling it then, if it actually has to be connected to a host machine? So I wanted to show him sort of an idea of building a peripheral that reacts on some sort of event on your computer. So that turned into hacking a porg toy to scream whenever my build failed. And I'm going to show you how I did this. But there's a content warning here. You might see the insides of a toy porg. So this is the porg. Get emotionally attached before the next couple of slides. So this is just a toy from Disney that has a nice feature that if you press the belly, then it starts screaming and waddling around and stuff. So I ordered this off Amazon, and then I took a screwdriver. It was actually lying around in my apartment for a couple of weeks. But then I had a free Friday evening, and I was like, I think it's the right time to start with this at least. So I took a screwdriver and started disassembling this, removing the fur, removing it further, opening the entire thing up until we finally ended up at this beautiful something. But I really just wanted to get to this green microcontroller that you see there, which is the control plate that controls the entire porg. And this one was interesting for me because I could have gone and kind of went straight to the speaker and then tried to trigger the speaker. But if you want to do the same sort of sounds as the porg, then you would have to figure out how to control the speaker correctly, which is a lot of work. So instead, my idea was, what if I can fake the button pressing of the belly? So that's what I did by removing the button. This is how it looked like. And you see the S1 thing, and that's where the switch was. And I removed it and looked at it, and I found these two pins where you actually already see the cables here that I realized if I connect two cables there and then connect these two, I can bridge the button. So I soldered two cables on there. The left one is not so beautiful because I had to surface mount that because I didn't have a drill to kind of like punch a hole in it, and there was nothing that I could attach this to, so I just surface mounted it. It's still holding, so it can't be too bad, but I'm fairly certain that anyone who professionally solders is going to hate me for this. And then I went to the electronics store and I bought a device called an optocoupler, and kind of configured, wired up the entire thing. So the black thing in the middle on what is called a breadboard, the white thing, is an optocoupler. And to give a bit of cleaner wire up, this is how it looked like. The LED is something that you can just have like for debugging purposes. But essentially the black part is an optocoupler. And an optocoupler you can imagine as, it essentially has inside in a tiny LED and a light receiver. And it's used to kind of emulate a switch to kind of, that you can trigger programmatically from a different circuit. So we have our Arduino circuit, and then we have the circuit of the porg, and they are not connected because of the reason that I'm powering the entire porg with the actual built-in batteries it had, instead of trying to power that with my microcontroller. So that's why I needed a tool like the optocoupler. And then I kind of wired up everything again, put the wire outside of the porg, got it dressed again, and this is sort of the setup that I had. And you know, just like in every good cooking show, I got something prepared. Let's see. There it is. So this is going to be a bit annoying, but definitely less annoying than for my flatmate when I hacked this and I was testing it the entire time, and it would scream the entire time until he would come into the living room and be like, "What the hell are you doing here?" So this is the porg. It has right now this beautiful case in the back, which I want to turn into a backpack so it looks a bit nicer. But let's switch into coding. So before I show you the actual code of the porg, I figured let's actually write this in a way like how it's actually implemented so you get a better idea. So just like on the slides earlier, we're going to grab the board instance from Johnny 5, and we're going to create a new board. And once we have that, we can listen on an event, like the ready event, and then we're going to trigger a function called scream. So we're going to create an async function scream. And now I need two things. I need the pin instance from Johnny 5, so we're going a bit more low level. Like Johnny 5 has a lot of things built in, like relay classes, LED classes, button classes. It doesn't have one for optocoupler, so we're going to use the pin manually. And then I'm going to grab the delay one as well. So I have that. And we're going to create a new pin instance here. It's listening on pin 4, and we need to set the mode to pin.output. And then what we're going to do is we're going to say start screaming, little porg. And we're going to set the pin value to high. So this is just going to put voltage on that respective pin. And then we're going to sleep for, let's say, 500 milliseconds. So we're emulating basically the same behavior as a button. And then we're going to set it to low again. And that's all we have to do. So we save this code. Let's move this up, clear it up. And then all we're going to do on the host machine is run node. So no magic here. Just wanted to make sure because it's going to start walking. See. So this is the debug version, and don't run. All right. So this is how that works. So the nice thing is, yeah, it will continue running around a bit. I still haven't figured out that thing. It's just the behavior of the porg. So you just got to deal with it. I'm gonna let it it will talk a bit over the time. So the nice thing is that it has a REPL, so you can actually kind of play around with stuff straight from here as well. You can inject stuff into the REPL. So we could actually, I think it's this, no. So we have all the pins here. We can actually take the pin 4 and actually set it to high. Oh, that's not how it, anyways. So basically, this is how that code works in a very small nutshell. But what I then did is I actually went way too far with this. So I wrote a command line tool for this. So we have a success JS here. It just console logs something, but then we also have an error JS, and it writes to standard error. And the idea was that I write a CLI tool called porg that we can specify here, where we can execute any arbitrary command, and if it writes to the standard error, or if it writes to, or it exits with a non-zero status code, then it will start screaming. So if we run success, it will literally just do what it's supposed to do. But then if we do the error part, it's going to start wobbling again. It was quiet this time. Go on. There we go. Stop walking. All right. So how does this look like? It's literally the same code, just with a bit of synthetic, a bit of sugar. So stop. No. All right. So basically, what I'm doing here is simply to make sure that if this will be triggered multiple times, I'm kind of buffering them up. And that's just because I'm reading from standard error. And if you would write multiple lines, I don't want to trigger the same thing multiple times. But under the hood, it just uses the same kind of the pin we're using. And then the trigger part is just setting it high. Here it's sleeping for a second, and then it's setting it to low. But it's the same behavior. And then I kind of just wrap that into a stream. So in this case, we're just literally writing to it, and then kind of using a timeout to make sure that if you're writing multiple times, that's not causing anything. And then in the index, in the bin, which is the actual command line, I'm just piping sort of standard error through it and then writing it again, and also checking for the exit code. But under the hood, so this means that we can sort of write any kind of node code, and then at the same time control some hardware at the same, as a sort of side effect. All right, back to the slides. Oh, I should actually press play. Cool. So let's talk about pros and cons here. The nice thing about Johnny 5 is that it allows you to write hardware-independent code. So that means you don't have to actually worry about, like, what if I use now an Arduino, but next week I want to use a particle or something else. And then it allows you to use familiar tools. So as you saw, I'm just using my favorite code editor. I can use things like TypeScript and then transpile the code and run it. I can leverage the entire Node ecosystem. In this case, I just use the delay function. And the website of Johnny 5 is a really great website for beginners because, first of all, the library itself has a bunch of built-in classes like relay classes and button classes and stuff. But they also always have schemas that show you an example wire-up for these things. And I think that's really useful if you're new and you're like, so do I need like a resistor for an LED, or can I just like hook this up directly? It shows you all of that. As for cons, you often have to have it tethered to a host unless you're using something like Raspberry Pi or a particle, and there's less examples than for classic Arduino projects. So you kind of need to figure a few things out yourself or port them over from Arduino. The next thing is untethered node bots. So untethered node bots is the idea to run JavaScript directly on the microcontroller. And there's a bunch of different ways to do this, actually. So one of them is called JerryScript, which is an ultra-lightweight JavaScript engine for the Internet of Things, according to themselves. So I just copy-pasted that. And that just allows you to run JavaScript directly on a microcontroller by actually writing some C++ wrapper code around it. One step further is Esprino. So Esprino is also a JavaScript interpreter, but you can run this either on its own hardware, and that's how this looks like. That's one of them, which is the Esprino Wi-Fi, but there's also things like Esprino Pico, and I think like by now like 5 or 6 different ones. I actually have some of them with me. If you want to take a look at them later, I'll have them at the Twilio booth. And the thing is, it can run on an ESP8266 as well. So as I said, that was the thing we used earlier, which costs $2 a piece. And it has, as I said, it has its own versions. They're all open source. So if you want to take a look at that and you're really convinced you want to create your own PCBs, go ahead and do that. But all of this code, all of the hardware is open source. It has its own IDE, which is basically a Chrome app. But it works pretty well. Unfortunately, the NPM support is limited because while it has a similar Node-style package system, it doesn't implement the entire Node.js API, and therefore not every module will work. And it does not work with Johnny 5 because of those reasons. There's a new kid on the block. They were just at JSConf EU last week or 2 weeks ago. And that's Neonius. It's a microcontroller that has a bunch of pretty cool features. So this is how it looks like. It has Ethernet on it and Wi-Fi on it. It sort of looks similar to a bunch of other microcontrollers. So it also has like digital pins and stuff. It's currently on Indiegogo, so they're still kind of kickstarting this, but they gave them out at JSConf EU, so I actually have one with me. I didn't get time to tinker around with them yet, but I wanted to talk about it. It comes with its own IDE. It's running in the browser, so it's a cloud-based. It's not a cloud-based one because it's running on the device, but it's a browser-based one. The cool thing is it supports things like TypeScript out of the box, and it supports the full Node ecosystem. It doesn't run actually Node. It runs a thing called Low.js that they wrote, which is just another JavaScript interpreter with a smaller memory footprint. However, it exposes the same API, and therefore you have NPM support. And as I said, it has built-in Ethernet and Wi-Fi, which is nice in case you want to have a more stable data connection, or you're in a situation where you can't have Wi-Fi. And then there's another thing called the Tesla, and I'm really excited about the Tesla. It's another open hardware project. This is how the Tesla 2 looks like. It has a lot of things that are really cool for beginners, everything from Ethernet and Java and like USB-A ports to things like digital and analog pins. But then it also has these things on the side where you could clip on modules that they built. And the cool thing about the Tesla is that it runs actual Node.js. with almost the entire NPM ecosystem supported. I'm saying almost because the thing is that it runs, the Tesla runs OpenWRT, which is a Linux distribution that would run on things like your router at home likely. And therefore, if you're using some native modules, if they can't compile, then you can't run those on the Tesla. It's compatible with Johnny 5, so that's really cool because it allows you to take your code that you wrote with Johnny 5 and then move it onto the Tesla. And since the Tesla can run Node, it actually becomes an untethered Node bot at that point with the same code. As I said, it's open source and open hardware. There's no company behind this. And because there's no company behind it, it's a bit more expensive. I think it's around like $30 or $40 for the device, but it's a cool device if you want to really get started with hardware hacking. It's definitely not the device you want to choose if you want to have sort of measure every point in your apartment. You don't want to spend that much money on the Tesla, but it's a great board that can do a bunch of things and is able to get you started quickly. It also comes with a CLI, so you can really nicely get started with it. So I built something with that as well. Typically, I fly this to events. I had to fly a bunch of other things here, so I couldn't bring it, but I still want to talk about it. So last year in April, I actually hacked a coffee machine using JavaScript. And the idea was I wanted to control an existing device using JavaScript. And I wanted to build a REST API because, as I said, Twilio is all about APIs. So I love APIs and playing around with them. And my REST API was supposed to implement the IETF RFC 2324. If you're not familiar with that, because you're not following IETF standards, maybe HTC PCP sounds more familiar to you. And if that's still confusing you, that's Hypertext Coffee Pod Control Protocol. That was a standard proposed on April 1st, 1998 by the IETF. It is an actual proposal. It was meant as an April Fool's, but it does exist. And if you ever stumbled upon the HTTP status code 418, I'm a teapot, that actually comes from that proposal. So it's not, contrary to popular belief, it's not actually a standard, but it was proposed as a standard. And the purpose of the I'm a teapot is to reply if your coffee pot is actually a teapot so that you know you're talking to the wrong device. And it has amazing things in there, like the brew method, which is acting the same way as the post method, but it's meant to brew coffee. They specify explicitly in there, though, that you might also use this later for a beer brewing protocol. So if any one of you wants to write that, maybe first read this. So why did I use the Tesla for this? First of all, the coffee machine should be untethered. If I need to plug in a computer to trigger my coffee machine, I'm doing something wrong. And then I wanted to use Johnny 5 to easily be able to swap out microcontrollers in case I want to use the Tesla for another project. I didn't want to buy a new one, but I could, for example, plug in a particle photon that I have flying around. It has to be internet connected, so that's another important thing. And the Esprino and the Tesla had an Ethernet cable as well, so that allows you to have a bit of a more stable connection. The setup with it is really quick and easy because the alternative for me would have been to use a Raspberry Pi, but the Raspberry Pi would have required me to actually set it up, install Linux, install Node on that Linux, and then kind of push the code over and then run it, and set up a boot script that automatically runs this every time it boots up. So instead, because this was a one-night project, which I'm going to show you in a second, I decided that the Tesla seems a more viable option because I can upload the code, and at that point, it will just run it. And because we needed to build a server, NPM packages are helpful, so that's one more reason to use something like the Tesla or a Raspberry Pi. All right, so how did we hack this? This is the coffee machine that my flatmate had flying around and didn't need anymore. So we were like, cool, let's hack it. Now, neither me nor my flatmate with whom I hacked this on a Friday night were or are electrical engineers. I studied 1 year electrical engineering back in university, but forgot everything, which you will see in a second. I think my professors would not be proud of me. But how did we get started with this? We got started like every good hacker does. We take a screwdriver and we just took this entire thing apart. So we removed the casing and stuff like that. until we got to this part. So that's the side view on one side and the more interesting side for us. Not because of the water pump, and sort of like all the other interior there, which kind of freaked us out for a bit because it's not a device that has low voltage, so be aware of that. But there were 3 interesting things in there that were useful for our project. And those were these 3 things. So the microcontroller, which is sort of the brain of the device, and then the buttons on the outside, and then what I labeled as interesting cable. And the reason why it was interesting is because it was a detachable cable, which is always nice because we can take things apart. And that meant we could take out the button plate, which is basically hidden in a casing on the left side. And that's how it looked like. And at the bottom, that's where the cable was attached. And the idea that we had was, if we can figure out the protocol that is being sent between the microcontroller and the control plate, then we can fake the protocol and actually send that over to the microcontroller to manually trigger these things. So the way we did that was we took the cable and jammed in a bunch of jumper wires. This is from later because I forgot to take a picture of that. But then we connected one side to the button control plate and then one side to the Tessel, and we tried to send signals around to figure out, hey, like what if I set one pin to high, because we didn't even know which ones were power and stuff, right? There's no documentation that in your coffee machine where it's like, oh yeah, so in case you ever open your coffee machine and happen to take the button control plate out, the following cables are providing power. So we were like trying to figure out how this works. So we set different pins to high and low and kind of wrote scripts that would iterate over this and see if we could turn on the LEDs on this thing. So there are like 7 LEDs on it. If we could turn those on, and afterwards if we would set voltage on different pins, if we would press a button, which ones would be triggered. And so we wrote a bunch of scripts around that, and I'm going to show you in a second how this looked like. But ultimately, that all failed, and it was 4 a.m., and we got slowly frustrated. And that was when we took this picture and decided to do a different approach. We wanted to turn this into a more clear diagram for us, so that looked like this. And basically how this happened was we looked at the lines here, which are actually more cleaned up than what we did. But then we found like 2 points and that we thought were connected, and then one of us would take a resistance measure device, which is called a multimeter, and measure the resistance between 2 points. And if it was 0, that meant it's indeed connected. So that way we were able to wire up this thing, which gave us a bit of information according to for the LEDs. So we were able to control every LED on that board except one that we broke during testing because we kind of put too much voltage on that pin. But overall, we managed to control those, but we didn't know how the buttons worked. So we went back and kind of cleaned this up, removed all the LEDs, and ended up with this. So that's a bit more cleaned up, and it gave us a better understanding and also showed us a problem with the approach that we took. And that was because we thought there was some digital protocol sort of with like, like if pins 3, 4, and 5 are high, then that's switch 6 pressed or something. But instead, sort of all 6 buttons were going out to the same output pins, but were based on 3 different input pins. And that meant that we couldn't actually send like an actual signal over because we were depending on the voltage that is coming on pins 1, 2, and 3. So instead, what we went with were relays. So relays work similar to optocouplers, not on the inside, but on the overall concept of them, which is we have some way of like basically triggering a switch from a microcontroller. And then what we did here is we just wired up sort of the same behavior as here, just for one side. And then we put in the LEDs that would be the control LEDs for this. So these 3 switches were able to allow us to make an espresso, make a large coffee, and turn the device on and off. And then the 3 LEDs were sort of representing the same stages. And then we had the wire up, which looked like this. The large blue thing is the plate of relays. We ran out of jumper wires, so we just turned that upside down and jammed it into the breadboard, which worked. And stayed like that for a long time until I met someone at a conference who was like, oh, I have some jumper wires on my back, and just grabbed them out. I don't know why you fly with them if you're not doing a talk like me. But he did, so I'm grateful for that. And then we closed the entire thing up, put the wires through the hole where the buttons used to be, and then wrote some code around this to actually have an API. And I figured I'm going to show you this quickly. Even though I don't have the coffee machine with me, at least that still shows you how the code looks like. So on the one hand, we have, let me show you first the debugging file. So this is the debugging file. We did a bunch of different things, sort of from trying to set buttons and then trying to match things to sort of every other approach. We injected things into the REPL to read stuff. My favorite line is this one, which I wrote it, I think, at like 5 a.m. And what it does is it creates binary flags, like it creates an array of binary flags that we can iterate over to set different pins to high and low. But then eventually, once we figured it out, we wrote 2 files. So one is called Latissima.js, just because that's the name of the coffee machine. And in here, what we have is sort of the same approach of creating a board. In this case, we're using the I/O plugin for the Tessel. And when the board is ready, we initialize the pins. So in the initialization, we create relay instances, which just comes straight from the Johnny 5 library. And then we make sure that they're closed. And in order to actually press a button, what it does is it will just open the relay and then close the relay after a while. So it's sort of the same behavior that we did with the porg. Now, if I go into the server, that's literally just using the HTTP module. Express was a bit too big, so I decided to write this manually. But I'm using external modules like the raw body and the local tunnel. The local tunnel module was important for me because it allowed me to create an externally addressable URL whenever this thing boots up. So that's what I'm doing here. I'm basically creating this URL. And then once that's done, I'm initializing the coffee machine and then handle the request. So I make sure that my coffee machine is not a teapot. And then I react on the post and the brew method here. This is completely according to spec. I actually found some bugs in the spec and extended a few things. I'm checking if it has the right additions. So in this spec, they actually thought of things like adding different syrups and stuff like that to your coffee. So if you're a thing of that, it's really helpful. But yeah, that's basically how this works. As I said, this is the wire up. I don't have the coffee machine with me right now, so no demo there. But if you want to get a better idea of how this entire thing looks like, I wrote up a blog post about this, which is on the bit.ly link, that explains all of this and goes more in detail of all of our failures and failed approaches and what we tried to do, but also how it ultimately worked out. And the entire code, including the debugging script and stuff, is on that GitHub. I'm going to share the slides afterwards if you want to check that out. Let's talk about pros and cons again. So untethered systems running JavaScript, that's great because we don't need to connect a computer to it. We can use a familiar programming language and familiar tools. So, for example, for the coffee machine one, I'm actually running that through TypeScript to downtranspile it to a Node version that is running on the Tessel, so that I could use more modern features. Could use Babel for that as well, or anything in that direction. You could even bundle things up and tree shake them if you want to keep your memory footprint small. You can bring your own editor and IDE, as I showed. Like I was doing exactly that, and you can potentially use the entire NPM ecosystem. You're typically less flexible on the choices of the devices, though, because most of these things have hardware attached to that you need to use. And you're likely going to miss cutting-edge language features, because in the case of the Tessel, it at least uses Node, but it takes a while until it updates the version of Node that it's using. All the other ones have their own interpreter. So unless they go and actually implement the feature, or you jump ahead and implement it for them, you will have to wait until they actually introduce that feature. And some of the documentation of some of these projects is better than others, so you might want to check that out before you make your decision. So how do you get started, now that I showed you all the options? First of all, you need to find a project. I believe that rather than first learning all the basics of electrical engineering, a more use case driven approach makes more sense. Like, you don't have to understand how to build an entire circuit if all you want to do is like control your coffee machine, you know. And then basically hack on existing projects or hack on existing devices. Take something that you have flying around that you're fine with potentially breaking, because that might happen. And then start off with that to get more comfortable with this. So take it apart, start understanding how it works, because I think that's something we just don't do anymore. You know, like when I was a kid, I would take apart my computer to understand how it works. Now I can't even take the battery out of my laptop or my phone. And I think we should get back to understanding how the devices that we use work. You might want to learn some electronics basics, but that's just like, what's the difference between voltage and current and resistance, and how do they intermingle? And sort of these things, and like, how does the current flow? But you don't actually have to have like an electrical engineering background or degree. A couple of things you should have at home if you want to do hardware hacking: a digital multimeter, which allows you to measure things. A breadboard, so that's this whiteboard that you seen earlier with the holes in it, so you can actually build things together without soldering them together. Plenty of jumper wires, so those are wires that you can fit into those breadboards. A set of resistors, because you will always need them, and you can just order a bag on Amazon and they're not expensive. A few LEDs, same goes for that, like they're not expensive at all. And a few solid-state relays, which is the relays that I use for the coffee machine, are helpful, because that's always good if you just want to trigger a button. It's the easiest way to get started with that. There are a couple of kits that I like. This is the Johnny 5 Inventor's Kit. I got that one. It's by far, from the ones I'm going to show you, the most expensive one, because it has a Tesla in it. But it's a nice one because it comes with a lot of documentation on how to get started as well. That is exactly made for this kit. So it's a cool way to get started, but as I said, it's a bit more expensive. If you don't feel comfortable yet with kind of handling resistors and stuff, Seed Studio made this thing called Grove, which is basically a bunch of small components, hardware components, that you can connect with wires that really only fit one way, so it's really hard to mess this up. And you can connect that to an Arduino then and work from there. So that's a good way to get started, but it kind of locks you into their ecosystem. So you have to be aware of that if you want to get started with that. But you can also just buy any generic Arduino starter kit. So this is not one that I particularly like picked out. I literally just went on Amazon and typed in Arduino starter kit. So figure out what kind of suits your need, but you can see that all of them have at least breadboards in there, resistors, LEDs, and the bottom things are jumper wires. This one actually has a relay in it, so the bottom right thing is a relay. But all of them sort of provide at least the minimum of it. So maybe look at it if you don't have a starter kit yet, and you have a project in mind, maybe first get an idea of what you will need by kind of Googling around a bit, and then afterwards get a kit that potentially already has these things in it. As for resources, so I put up the slides on the top URL. I'm going to tweet it as well. I encourage you to check out the next two links, which is one of them shows you how I hacked a coffee machine. The other one is a blog post that teaches you how to get started with Johnny 5 and an Arduino, kind of taking you through the entire process of it. Notebots.io is cool because it shows a bunch of different tutorials and stuff. Johnny5.io is the documentation for Johnny 5, and Tesla.io is for the Tesla project if you want to check that out. And with that, I would like to thank you all for your attention. And if you have any questions, I'll be at the booth, so you can just come by. I'm going to leave around like 3 p.m., but until then, I'm going to be there if you have any questions. And thank you all. Have a great day. Hey. Oh, I'm still.